first grade teachers. Welcome to the Unit at a Glance video for Unit 2B. The purpose of this video is to provide you with an overview of the standards, intended pacing, and sample instructional strategies for Unit 2B, building and explaining the relationship between addition and subtraction. In this portion of the video, we are going to review the AKS and Indicators of Achievement, or IOAs, for Unit 2B. The AKS is the overarching knowledge and skills that students are expected to master. The IOAs are the learning objectives that allow students to demonstrate mastery of the AKS. Remember, some AKS and IOAs will appear multiple times throughout the year to build and deepen student understanding. In Chapter 2 of the video, we will look to see how the AKS and IOAs in this unit are paced in detail. Let's look at the AKS and IOAs we will be teaching in this unit. Unit 2B has two AKS, AKS 2 and 6. Under the AKS, you will find the indicators of achievement that we are teaching at this time. Notice for AKS 2, we are focusing on the IOAs 2E, 2F, and 2G. For AKS 6, we are only working on the IOA 6D at this time. AKS 2 involves solving addition and subtraction problems within 20, explaining the relationship between addition and subtraction, and applying the properties of operations. The IOAs go into further detail about the expectations for the standard. For IOA 2E, students explore and explain the relationship of the equal sign to the quantities and justify if equations involving addition and subtraction are true, meaning the quantities are equal or the same as, or false, not equal. In IOA 2F, students use their understanding of addition and subtraction strategies to determine the unknown number that makes the equation true. Symbols are used to represent unknown amounts in all positions of an equation. With IOA 2G, students discover and apply the commutative and associative properties of addition as strategies for solving problems. Exploring the properties gives students an opportunity to realize the sum does not change even when moving or grouping addends in a different order. Using the commutative and associative properties as strategies builds flexibility for computation. AKS 6 is our measurement and data standard that we are revisiting in this unit. We are continuing to focus on analyzing graphical displays of data to answer relevant questions. In IOA 6D, students collect, organize, represent, and interpret data to answer questions about their world with up to 3 categories. Students are provided with opportunities to create and explore statistical investigative questions by collecting and analyzing data. Now let's look at the pacing guide to see how the AKS and IOAs have been paced out over the course of Unit 2B. In this top portion of the pacing guide, we see the name of the unit, the big ideas for the unit, and the suggested pacing. Unit 2B will focus on numerical reasoning and measurement and data reasoning. The suggested pacing for the unit is about 4 weeks. In the next box, we see the first AKS and IOA that will appear in the unit. Unit 2B will begin with AKS 6, IOA 6D. The left column of the pacing guide will list the progression through concrete, representational, and abstract strategies. The bullets also indicate the learning objective for the day, as well as any suggested manipulatives. The right column of the pacing guide shows the instructional resources that align to the intended learning objectives for each day of instruction. You will either see instructional resources linked for the numeracy components of a traditional teacher-led lesson, like this third day here, or a task-based lesson, which will be your full numeracy block for that day. Notice the first and second day of the unit. For IOA 6D, we are starting with about 3 days of instruction. This IOA has already been introduced and will continue to be revisited throughout the year. As you dig into these lessons, you will notice that the focus of instruction has shifted to more of a student-driven approach using the statistical reasoning framework to provide a richer, more meaningful experience with data. Students will begin with a Georgia DOE task-based learning plan that has been paced over the course of 2 days, where students will engage in the full process. They will determine categories for a statistical investigative question, collect data using a tally chart, represent the data in a graphical display, and analyze and interpret the data. The third day provides explicit instruction on comparing sets of data and answering comparison questions as they interpret the data. To see the statistical reasoning process in action, refer to the Analyzing the Standards. We then move into IOA 2G for about 5 days, as students will be applying the commutative and associative properties of addition as strategies to solve problems within 20. Students are not expected to know or refer to the names of these properties. Students will use concrete manipulatives like snap cubes and 10 frames to explore the concept of changing the order of the addends and realizing the sum remains the same. At the representational level, students may show this by drawing pictures or utilizing a number line. With the associative property, when working with 3 addends, the goal is for students to look for efficient ways to group the addends using strategies they've learned, like doubles and making a 10. As we move into IOA 2E and 2F, we will begin with about 5 days of instruction to continue 2E from Unit 1B to now model and explain the meaning of the equal sign and use that understanding to determine if equations are true or false. Students will do this by physically acting out the expressions on each side of the equal sign using snap cubes in a bucket balance. This will show students that if both sides are the same and it is balanced, then the equation is equal or true. If one side is more or less than the other, it means the equation is unequal or false. At the representational level, students may use drawings when solving equations to determine if they are true or false. Abstract thinking would be applying any of the addition or subtraction strategies they have learned to solve for the quantities on each side of the equation. IOA 2F is clustered with 2E for about 4 days as students use that understanding of the meaning of the equal sign to now make the equation true by determining the unknown in any position. They may do this with concrete manipulatives like snap cubes and counters, or using representational strategies like drawings or a number line. Keep in mind that students really have been doing this work all along as they have been solving a variety of problem types with the result, change, start, or part unknown. Chapter 3 of the video will highlight specific instructional strategies that will be utilized in this unit. Please refer to the Analyzing the Standards document for guidance on additional instructional strategies for each IOA. I am going to highlight strategies that will be used for IOA 2E, using the meaning of the equal sign to determine if equations are true or false. So when students are exploring this concept, it's beneficial for them to begin by using a math tool like a bucket balance and concrete manipulatives like snap cubes in order to act out the quantities on each side of the equal sign in an equation. And then they can physically see if those two quantities are the same or equal, making that equation true, or if the quantities are different. One side is greater or less than the other, which would make that equation not equal or false. So we're going to use this today and actually explore one of the student tasks that's linked on the first day. So after the mini lesson and after students have seen you model using this bucket balance and snap cubes, then they will engage in this partner task. Now, when I'm modeling this, I like to also include a sticky note here showing that equal sign and then the phrase the same as. So as we're reading our equation, we can see, oh, are those two quantities on either side the same as each other or not? Okay, so part of this task, what students are going to do is they will select an equation, right? So I'm going to put one of the equations that students may be working with here. 8 equals 4 plus 4. And they have to work with their partner to try to determine if this equation is true or false. So I'm going to look here first at the left side of my equation, and I see the quantity of 8. So what I'm going to do is I'm going to count out 8 snap cubes, just like the students would on the left side of the bucket balance. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I've placed 8 snap cubes on the left side, and then I can see the right side of the equation. I actually have an expression, 4 plus 4. So I'm going to use 2 different color snap cubes, but really students could use any color as long as they are counting out these 2 quantities. So I'm going to start with 4 snap cubes. And then I see that plus sign, so I'm going to add 4 more snap cubes. 1, 2, 3, 4. And as I do that, I can see that my bucket balance is starting to level out, right? It's starting to balance itself, and it's looking like these 2 quantities might be equal to each other. Now, some of your students may know their doubles and know that, yes, 4 plus 4 also equals 8. Other students may want to double check here, and we can do that just by dumping out these cubes and counting them all together. 1, 2, 3, 4, 5, 6, 7, 8. So when I count 4 plus 4 all together, I do get 8. And I can visually see that 8 is the same as 8. Both sides are the equal quantities, which means that equation is true. Okay. So then students would take our equation and they would sort it. So they're going to have a T-chart with true and false. So this equation would be sorted under the true column. Okay. Let's take a look at another equation that students may encounter in this task. 11 equals 9 minus 3. Okay, so I'm going to look here at the left side of the equal sign, and I see a quantity of 11. So I am going to fill that bucket with 11 snap cubes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Okay, so I've represented that quantity with 11 snap cubes. Now I'm going to look to the right side of the equal sign and I see an expression, this time a subtraction expression, 9 minus 3. So I'm going to begin with my 9 snap cubes. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, now I need to subtract or take away 3 of those snap cubes to complete solving this side of the equation. So I'm going to remove 3 snap cubes. And when I do that and I look at the balance, I can clearly see that it is tilted, that the left side is much heavier or more than this right side that is lighter. So I am thinking that this equation is not equal, that these two quantities are not the same. Now, just to check how many snap cubes I actually have on this side, some students may know that 9 minus 3 or count back from 9, 3, or we can again count out what's left. 1, 2, 3, 4, 5, 6. Okay, so when I had 9 snap cubes and I removed or subtracted 3 of them, I was left with 6 snap cubes. And 6 is not the same as 11, which means this equation is not equal, so it is false. So you can see that using this bucket balance and the concrete manipulatives of snap cubes gives students that opportunity to physically act out this equation in a very visual way of seeing if equations are balanced, they are equal and true, or if they're not balanced, meaning that they are not the same and it is a false equation. Now let's look at a representational strategy that students may use when doing this work with IOA 2E. So let's look at a problem from one of the lessons on the pacing guide. Determine if the equation 5 plus 4 equals 12 minus 3 is true or false. Justify your thinking. So I'm going to rewrite our equation here in our workspace. And one thing to point out and for students to notice is that now we actually have an expression on both sides of the equal sign, right? So we're going to need to solve both of those expressions and determine their value so that then we can see if indeed they are the same amount and it is a true equation, or if they're different and it's not equal or false. Okay, so we have an addition expression on this side and a subtraction expression here. So I'm going to use a strategy of drawing a picture to help me solve this problem. So here I can see I have 5 plus an additional 4. So I'm going to draw my picture to represent 5. And then I'm going to draw 4 more to show that 5 plus 4. And then I can use that counting on strategy. I know I have 5 and I can count on 6, 7, 8, 9. So here in my picture, I can see that 5 plus 4 has a value of 9. Then on the other side of the equal sign, I see 12 minus 3. So I'm going to start by drawing 12. Okay, so I've represented the 12, and now I'm going to remove or subtract 3 of those circles. Now, to determine the value, students may count what's left here in their picture, or they could count back from 12, 11, 10, 9, to see that there are 9 circles left in our picture. And so here I can see that 12 minus 3 also has a value of 9. So since both expressions have a value of 9, 9 is the same as 9, 9 equals 9. So I can say that, yes, this equation is true. Now, one thing that you want to point out when you have expressions on both sides of the equal sign is sometimes students will look at 5 plus 4 equals and they see a 12 right after the equal sign. So when they solve 5 plus 4 and get 9, they may jump to the conclusion that, oh, no, it's not equal because 9 is not the same as 12. And they're only looking at this first number after the equal sign and thinking of that as the answer, when really we see a full expression here, this subtraction expression, that we also need to solve and find that value before we can determine if this equation is true or false. Now let's see how students will use that understanding of the meaning of the equal sign from IOA 2E to help them determine the unknown in an equation, which is the work of IOA 2F. So we talked about in the pacing how 2F will begin to be clustered with 2E as students are making that connection between those two. So let's look at this problem from a lesson on the pacing guide. Find the missing number for the equation 12 equals 8 plus triangle, right? So we can see that we have an unknown amount in this equation represented by the symbol of a triangle. And I can read this equation as 12 is the same as 8 plus an unknown number. So what I need to determine is what that unknown number is. Okay, so one way students might do this and help them think through this equation is with a part-whole math, right? So when I'm looking back at my equation, I see that I have a sum of 12, right? That 12 is my total or my whole. So I'm going to write 12 here. And what I need to do is make this right side of my equation equal to or the same as 12. So I see I have 8, which is one of my parts, plus the other unknown part represented by a triangle here. So these two parts need to equal that 12, the whole. So I'm going to use some counters here to help me think through it. So I know I have 8. So I'm going to put down 8 counters in this part of my mat. So I've represented the 8 I know. And then to figure out this unknown amount, I am going to start at 8 and count on until I reach 12. So I'm going to get some more counters here. So I know 8, 9, 10, 11, 12. So now I have a total of 12 counters. To figure out this unknown amount, I can look at this part and count how many more I needed to add on to 8. And I see I needed 1, 2, 3, 4 more counters. So I can rewrite this equation now and replace this symbol with the 4. 4 is my unknown. So 12 is the same as 8 plus 4. The 4 made this a true equation because 8 plus 4 is equal to 12. The Georgia DOE's Comprehensive Grade Level Overview states, in mathematics, the emphasis is on the reasoning and thinking about the quantities within mathematical contexts. Specific mathematics strategies for teaching and learning are not mandated by the Georgia Department of Education or assessed on state or federally mandated tests. Students may solve problems in different ways and have the flexibility to choose a mathematical strategy that allows them to make sense of and strategically solve problems using efficient methods that are most comfortable for and make sense to them. It is critical that teachers and parents remain partners to help each child grow to become a mathematically literate citizen. These standards preserve and affirm local control and flexibility. Thank you for joining us for this unit at a glance.